Okay. Let's take a look.
I know, this is the longest period of my life. What? Wow. That was Z or T?
It's Z. So here are the steps.
I'm still writing them down.
Come on, you guys, got to hustle. It's a short day. You guys are moving a bit slow this morning.
It's not like we just got back from the movie.
Doesn't matter. School is school. We ready?
Yep.
Let's ramp up the level of maturity here a little bit so we can be ready to go. We have what do we got here? 55, 25 minutes. We got to get through most of this. Okay? So, step one is to choose two equations. And eliminate a variable. Doesn't matter which one. I would caution you, though, it would be best if you chose not to eliminate Z, and I'll explain why. Maybe not. We might not get to it today, but later on, especially for Objective 2, if you've eliminated Z from Step 1, it could make things a lot harder. So if you can, avoid eliminating Z. So just considering the system of equations, which two equations would you want to eliminate one variable from? There's one obvious choice here. If we choose the top two equations, without having to do anything, the two y variables will cancel. We have negative 2y and positive 2y right here. So for step one, I'm going to choose the top and the bottom one. X minus 2y plus 3z equals 1. X plus 2y. And try to avoid doing steps and math in your head for these. You're going to end up making mistakes. So write everything down. These are the top two equations. The y variable eliminates, and you're left with 2x plus 2z is equal to 14. That's step one. We've gone from 3 variables down to an equation with 2 variables, x and z. Okay, step 2 is to choose 2 different equations, of the original equations I'm talking about, 2 different equations. And this next part is important, and eliminate the same variable. Same variable from step 1. Why would we need to do that? From step 1, we came up with an equation in terms of x and z.
Because now you have to, because you still have 3 if you eliminate different ones.
Exactly. But in step 2, if you eliminate the same variable, you're going to end up with another equation in terms of x and z. And you can perform the same methods we learned last time from 10.1 and solve for 2 variables. So you have to choose 2 different equations. You can't choose the same 2 equations.
Let's do 1 of 3.
But if we chose this top equation and the bottom equation, wouldn't y eliminate right off the bat? So choose the top one and the bottom. X minus 2y plus 3z is equal to 1. 3x plus 2y minus 5z. Y variable eliminates and you get 4x minus 2z is equal to 4. Now step 3. Combine the two equations. From steps 1 and 2. And solve the system. So from step 1 we had something in terms of x and z. From step 2 we had something in terms of x and z. Combine them and solve the system for x and z. Once you know x and z, you can go back and find y. Now this one just happened to turn out super nice where everything just eliminated right off the bat and we didn't have to multiply by anything. It doesn't always happen that way. It would be nice, but it really doesn't.
It doesn't equal.
So the z's cancel. We have 6x is equal to 18, so x is equal to 3. Now you have to backward substitute up through the steps to the original equation. If all we did is took x and went right back to the originals, would we have enough information to solve for y and z? No. So you got to go back one step at a time. Once we know x, you go back up into here to find z. Once you have x and z, then you go back up to the originals to find y. So if x is equal to 3, then choose one of these equations from this middle step here to solve for z. So I'm going to choose this top one. That becomes 2 times x, which is 2 times 3. So that's 6 plus 2z is equal to 14. Subtract 6 on both sides, and you get 2z is equal to 8. And you get z is equal to 4. So we have x and we have z. Take both of those and choose one of the original equations. Doesn't matter which one. We've solved this as a system, so either one you choose would give you the same value for y. So choose the one you think is going to be the easiest. I'm going to choose, sorry, we can choose the middle equation. X plus 2y minus z is equal to 13. We know that x is 3, and we know that z is 4. Three minus 4 is negative 1. If you add 1 to both sides, you get 2y is equal to 14, so y is equal to 7.
So I screwed up.
Where?
I got all those numbers, but I have them all negative.
Try to find where it was that you...
I have no idea.
Here's how I'd like you to represent your solution, and I'm going to be strict on this on the test, so I don't have to search around an entire page to find your variables. You need to put it in the form of an ordered triple. 3, 7, 4. Yes?
Wait, which ones did you use to find the y? Which equations?
I used the original equations. I just chose one of them. I chose the middle one. You could choose any one of them. It doesn't matter. But I chose the middle one because it seemed to be the easiest.
Okay.
I plugged a 3 in for x and a 4 in for z. And that gave me this equation right here. Yeah.
Does it matter what order?
I see where I screwed up.
Yeah, it needs to be x, y, z. Let's do the same example, part B, new system. X plus y plus z equals 4. X plus 3y plus 3z is equal to 10. 2x plus y minus z is equal to 3.
Ooh, I see what you're doing.
Choose the first and last equation.
So it would be best if you tried not to eliminate z. It really would. Even though I know it seems like it would work out nice here.
You could solve for right off the bat.
How?
You just multiply the top equation by -3. Wait, no, that eliminates z. Crap, don't listen to me.
What if we multiply the top equation by negative? Then we could get rid of x from the top two. And there's, I mean, you could choose any two equations and eliminate any variable you want. You don't have to do the same one I'm going to. I'm going to multiply the top equation by negative 1 and combine it with the middle equation. And I'm going to eliminate x.
You're going to eliminate x.
Eliminate the x variable. I multiply the top equation by negative 1. X is gone. You have 2y plus 2z is equal to 6. So what I have is an equation in terms of y and z. We've got to do the same thing now to two different equations and eliminate the same variable, x.
The first and the last one.
So
Multiply by negative 2.
if we did the first equation and the last
The
equation,
first and the second one. Oh.
we already did the first and the second. If we did the first and the last, what would I have to multiply the top equation by? Negative 2. Okay, so I'm going to multiply the top equation by negative 2. It becomes negative 2x minus 2y minus 2z is equal to negative 8. Bottom equation stays the same, 2x plus y minus z is equal to 3. X is gone. Combine your variables. So the result of those two steps is equations in terms of the same variables, y and z. This is in terms of y and z. This is in terms of y and z. So you take those two equations, combine them, and solve it as a system of equations in only two variables, not three. We have 2y plus 2z equals 6. We have negative y minus 3z. This one doesn't solve just by combining variables. We have to change some things here.
I just multiply the top one by 2.
Multiply the top one by 2. Which one are you trying to eliminate?
Y. The bottom one? Yeah, the bottom one. Sorry.
That's okay. So you multiply this one by 2.
Yeah.
So that became negative 2y minus 6z is equal to negative 10. So z is equal to 1.
Yeah.
And you got to work your way now back through your problems. You can't take this one solution and go right back to the beginning and solve for the other two. You have to go back to the middle steps here. If you know z, go back and find y. Once you know z and y, go back and find x. So I'm going to take this z is equal to 1, plug it into this equation here. That becomes 2y plus 2 times 1, which is 2, is equal to 6. Subtract 2, that comes 4. Divide by 2. So we get y equals 2. Take both of these variables, now y and z, and choose any one of the original equations, but the top one's probably going to be your best shot. If z is 1 and y is 2, they all have to add together to be 4. So what does x have to equal?
1.
X has to be 1.
I got that one right.
Good.
Wow.
Again, though, you need to write this as an ordered triple 1, comma 2, comma 1.
Not looking forward to the application.
Let's do one more quick one before we get, well, we're not going to have time to get to objective 2. Let's do part C. This one always seems to throw students off for some reason.
It's gonna be super obvious.
It kind of is, but it always throws people off.
Hello, it equals 0. Whoa, there's 0 x.
It's the fact that it looks different, so students assume that it's way harder and they give up. But this is actually easier.
I give up.
There's no actions.
It's a 2.
Okay. I just added the 0 x.
Exactly. You guys, exactly. Some of you have seen it. In this equation that I've circled, what variable is gone? X is already gone. So my suggestion would be to take the top one and the bottom one, eliminate X, and then combine whatever you get with the middle equation. Because if you eliminate X from the top and the bottom, what variables are going to be left? Y and Z. So combine that result with what's already here with this middle equation. You've just saved yourself one whole step. So how would you eliminate X from the top one and the bottom? Multiply the top one by -1, that could work. That top one then becomes negative X plus Y minus Z equals 0.
I have a question. Once you get it down to 2 variables, can you eliminate Z?
Yeah, you just don't want to eliminate Z as a first step. You'll see why in the next objective. We won't get there today. So by choosing the top and the bottom equations and eliminating X, we've ended up with this equation. 2y minus 2z is equal to 2. We can automatically combine this one with the equation in the middle because it's already in terms of y and z. We don't have to eliminate X again because it's already gone from right here. So take the middle equation, y plus 2z is equal to -2. This equation here, 2y minus 2z is equal to 2. You can eliminate z now as at this step. Just try not to do it as a first step. But if you eliminate z, you're going to have 3y is equal to 0. So y is equal to 0. Now work your way backwards up through the original until you get to the original problems. You can't just take one value, go right back to the beginning, go back to the middle here. If y is equal to 0, I'm going to plug that into this equation here. If y is equal to 0, then what do we get out of that? Z is equal to -1. Okay, now you can go back to the original and solve for x. I'm going to choose this bottom equation here. If y is 0 and z is -1, this becomes x plus 0 minus -1, which is plus 1, is equal to 2. So we get x equals 1. So put it as the form of an ordered triple.